What's up, guys? We're going to be running a DOM-based cross-site scripting attack. We're going to be exploiting a vulnerability in the way that some AngularJS code has been written. Now, just some basic information. What is AngularJS? It's a JavaScript framework. It's deprecated or unsupported since 2022 and is being replaced by Angular, which is also a JavaScript framework, but it actually makes use of TypeScript. So it's really a TypeScript framework. Now we're going to get to the solution fairly quickly, but it's important to understand that the solution is really just the beginning in this particular lab. There's no point having the solution if we don't understand why the solution is working. At the time of creating this video, there is no decent explanation online as to why this particular exploit works. So we're going to be doing a bit of a deep dive into this particular vulnerability. So let's start with the vulnerability itself. The cliffs are as follows. JavaScript frameworks often evaluate content contained within these curly brackets. And we can often check for injection vulnerabilities just by providing a very simple JavaScript expression. For example, let's put 1+1 in between these curly brackets. Now, if the blog is handling input correctly, we should really just see these curly brackets and 1+1 echoed to the page. But if we click search, we'll see that we actually get 0 search results for 2, as if 2 was our input search string, but it wasn't. We can see that those curly brackets have been evaluated and the resultant value of the JavaScript expression has been returned, which is 2, the value of 1+1. Now, although we can execute JavaScript expressions, there are some safeguards in terms of executing JavaScript functions. So unfortunately, we can't just do something like put a JavaScript alert function within these curly brackets. If we search for that, you can see that's obviously been stripped from the page. There are clearly some security protocols in place. So I'm going to give you a payload which is going to solve the lab. Then we're going to have to try and figure out why exactly this is working. So the payload, it's going to make use of these curly brackets. We are going to use $, eval.constructor. In brackets, we're going to pass the JavaScript alert function as a string. So we're going to use single quotes here, alert. And then we actually need to call this function. So we need another set of brackets to indicate that the result of this expression, which is going to be a function, is then going to be called. Don't worry too much if it doesn't make sense at this stage. Let's just run this payload and you can see we get an alert box to the screen. Now, there are quite a number of solutions to this lab online, and in most cases, it's just someone pasting this particular payload into the search box. So I just want to emphasize that this is not hacking. Copying and pasting a payload is not hacking. The payload in this instance is the easy part of the lab. The purpose of this lab is to understand what the exploit is and why exactly the exploit's working. On another related note, sometimes web developers have the luxury of assigning themselves as developers of a specific framework. So you'll sometimes hear developers say things like, I'm a React developer, or I'm an AngularJS developer. Security researchers don't have that luxury. We need to be familiar with all of the available frameworks, at least to some level. And in some cases, we need to be aware of certain features of a framework that even the developers are not aware of, because we're approaching this from a different angle. We're looking to find security vulnerabilities, not to just understand how the framework works for development purposes. So to fully understand this solution, we need a better understanding of how AngularJS works. We also need a little bit of a deeper dive on how certain features of JavaScript work in order to understand this payload. So the best way to actually understand these concepts is to build a very basic AngularJS document. So just going to be a HTML document, and we're going to have some head tags, and inside the head tags, we are going to paste the CDN, so content delivery for AngularJS. Sorry, also just had to change the theme there. That color scheme wasn't doing it for me. This is the Abyss theme in Visual Studio Code. So we'll create a body section, and this is going to be where the actual Angular app itself is going to exist. And we make use of what's known as an Angular directive. And you'll recognize these because they always start with ng hyphen. So we want ng app equals, and we'll give this a name. So we're going to call it my app. And Angular apps also make use of a controller. And we can specify the name of the controller with ng-controller equals, and we'll just call it my control for simplicity's sake. So next step is to actually initialize our app. So we're going to say var app equals Angular. So this is what's been imported by that CDN. Angular.module. We pass the name of the app, and then we're going to pass an empty array. And now we can start building our controllers. We'll say app.controller. We'll again pass the name, which is my control in this case. And then we need to pass a function, and we need to pass a scope variable as a parameter here. And the idea here is we can now specify values in scope. So we can do something like scope.firstname equals Adam. And then within the Angular app itself, we can actually reference the variables that are in scope directly. Before we do that, though, let's just include script tags here because this is actually JavaScript. So I'll have script, and we'll just move that end script tag to after the code. And then we're going to pass in the variable that has been defined in scope, which is first name. Also, just as a quick example as well, just to mirror what we attempted on the lab, we can also pass in other valid JavaScript expressions such as 1 + 1. Obviously, this doesn't care about the scope since 1 + 1 = 2 regardless of the situation. So now if we head into our directory, let's just fire that up in Firefox. So we're first of all expecting to see our variable referenced from scope, which is Adam. And we also see the result of that JavaScript expression too. Now, if we add some additional brackets, and let's just pass in our payload. So it's a val.constructor. We pass in the alert function inside a string, and then we call that function. So let's save that. Let's refresh our Firefox page. So at this stage, we've essentially reproduced this cross-site scripting attack in our own lab, which we can experiment with. So the key takeaways so far is that we have access to certain properties that are defined within the scope, within the controller. And we have some user-defined properties in scope, but we also have a bunch of other properties, objects, and functions which are in scope of this Angular app. And one example of an in-scope function is $eval. Now, if you're wondering about the $, it doesn't really have any meaning. It's just a convention. JavaScript frameworks often like to prefix some of their methods with this $, just to indicate that it's part of the framework and it's not something that's been defined by the user. So it helps to keep that namespace clean. There's going to be no conflicts because the framework always is prefacing its methods with this $, so it doesn't have any special meaning by itself. Now, how do we know which properties and methods are available on the Angular app that we have access to? It would be nice to be able to access this scope from within the JavaScript console on the web browser. And there's a way of doing that. So a little trick here. I'm just going to create an empty paragraph and I'm going to assign it an ID of test. So we are back in our browser and we fired up the dev console. So I'm going to target that paragraph with the ID of test and get its scope. So the way we do this is Angular.element, and we're actually going to pass some vanilla JavaScript. There is a way of doing this with Angular. I prefer doing it this way, however. So document.getElement by ID. And we simply need to pass the ID of the element, which is test. We can then call .scope on the element that's returned there. And this is essentially our scope. We have access to this particular object. Now, just to make things a little bit easier, we can say let scope and just assign this fairly large piece of JavaScript to let scope. So now we can just access it through the scope variable. And let's expand that object. Let's see what's available. And we see a range of objects and properties available in the scope. But also we need to check out this prototype. So these are essentially not properties and methods that belong to the object itself initially, but they've been inherited from a parent. This is why we said we have to understand a little bit about how JavaScript works. And one of the important concepts here is inheritance. So anytime we create an object in JavaScript, it inherits some default properties, methods from the prototype. Just as an example of this, when we create something like an array in JavaScript, and by the way, JavaScript is not considered a primitive, but it's actually a type of object. And you're probably familiar with the idea that when we create an array, we have access to available methods on that array, which we didn't define ourselves. For example, we have access to something like .forEach. Well, we didn't define that on the array. It was just automatically there as part of the array. So where did that come from? It came from the prototype. Now, in this case, with the array, the prototype is something that's embedded into the JavaScript language. So every time we create an array, it automatically comes with these inherited methods. So it's the same concept here when we click on a prototype, but these are not necessarily properties that are inherent to JavaScript. They've actually come from higher up within the Angular app. In fact, what we need to do in this case, since we are operating from within inside a controller rather than the default Angular scope, we need to first of all go to parent and then go to prototype on the parent. And now we see various methods, notice they're all prefixed with the $, that are exposed to us and are technically within the scope of those angle brackets that we're using in the HTML document. Notice we have $eval. Now you might be wondering, what's special about $eval? And the answer is nothing. The main characteristic we're looking for here is simply that it's a function. Now, if you have a look at the lab guidelines and the lab solution on the Burp Suite Academy lab, you'll see that they don't use eval. They actually use $on. And in fact, we could presumably use any of the available functions here to launch this cross-site scripting attack. So why does any function work? What is the idea behind this particular attack? And again, we need to go back to some basic understanding of JavaScript. And I say basic, but it's possible that a lot of JavaScript developers don't know this. When I say basic, I mean it's a core fundamental feature of how the language works, but it's almost like it's low level enough that it's not usually touched by the average JavaScript developer. So for now, I'm going to get rid of this payload just so we don't have an alert popping up to the page each time, and we're actually going to run some vanilla JavaScript. Now, we are very likely familiar with the idea, regardless of whether we write JavaScript or not, we're probably familiar with the idea that we can code a function in a programming language. And the way that's usually done in something like JavaScript, like the default vanilla way of doing this is we say something like function, we give it a name, we can call it test, for example, and then we provide what that function does inside those scope brackets or those curly brackets. So we can say console log, which needs to be a regular bracket for the function. We can say hello world. And this won't do anything yet. This just defines the function. So if we refresh the page, nothing's going to happen, but we have created a function. It's just not being executed. So if we want this to execute, the next thing we do is we actually execute the function. We type the name of the function, and then we put those function scopes, the regular brackets, to indicate that we want to call this function right now. So if we head back to Firefox, let's refresh the page. We now see in the console, hello world echoed to the console. This is one of the first things that you learn in any programming language, really, especially JavaScript, how to write a function. What you may not know is there is actually also a function constructor function. It's basically a function for creating functions. And this is not generally used. And the reasons why might be explained very well by the MDN documents here. It says calling the constructor directly can create functions dynamically. We'll get to that shortly, but suffers from security and similar performance issues as eval. So in other words, when translated, it's saying you can do this. It's a feature of JavaScript, but it's not recommended. It's not the correct way of creating functions. Having said that, it works. So to head back to our JavaScript, let's apply that logic. And we can create a function using the function constructor. So we can say function, and the way it works is we pass the actual function as a parameter inside a string. So if we do alert here inside the function, we've actually created a function. Now at this stage, it's an anonymous function, but we can give it a name. So let's call it test, let test equals, and then we've used the function constructor. We've passed the code of that function inside a string. We've called it test, and then we're calling the test function. Now, if we head back to the page and we refresh the page, you can see we get the alert popped up to the page. And just so it's the same as the other example, let's see if we can console log hello world. So we'll do console log. Obviously, we need to make use of double quotes because we're inside a single quoted string. So hello world. Let's refresh the page now. We get hello world echoed to the console. So we've reproduced the original code, but this time we're making use of the function constructor, which is not recommended according to the MDN docs. But the point is that it works. Now, we gave it a name because without a name, it was an anonymous function. So if we just declare the function like this and refresh the page, nothing's going to happen because it's equivalent of declaring a function but not calling it. Remember what the doc said though, calling the constructor directly can create functions dynamically. So what does that line actually mean when translated? It means we can call this function directly. We haven't given it a name, but if we just add some function scopes on the end of this anonymous function, it will call the function. So it's creating and calling the function in one line. Let's refresh the page now. We get hello world echoed to the console. So thinking back to our exploit that we used in the lab, you can hopefully get a feel for what the additional scopes are actually doing. They're calling the function directly. Now, this doesn't explain everything about the payload because we still have the beginning of the payload, which was eval, or we can use on, does the same thing. Then we have on.constructor. Now, the question is, what is that .constructor? Now, we're hopefully familiar with the idea of a constructor function within a class. It's a piece of code that's executed when that class is created into a new object. In other words, it's a function or a method. What we're looking at here is not a method. It's a property of an object. And remember when we were talking about inheritance and prototypes? It's one of those properties that exists on objects and functions by default. We can see a quick description here on MDN. It says, the constructor data property of an object instance returns a reference to the constructor function that created the instance object. Now, if you were looking at the payload and thinking, well, this is not a property, it must be a method because it's calling these function scopes afterwards, then just ignore that for now. I'll get to that shortly. This is not a method, it is a property. And we've just seen it returns a reference to the constructor that created the object or the function that we're in. Now, don't worry if you're confused. Let's just recreate the regular vanilla version of our test function. So we're going to say function test, and all it's going to do is console.log hello world. Now, we've created a function, but there's going to be some inheritance here. In other words, that test function actually has some properties. And as an experiment, let's console.log test.constructor to the console, and let's see what we get. And notice we get this function with the name of function. Remember we said it was a reference to the constructor? Well, how are functions created behind the scenes? By making use of that function constructor, which creates functions. In other words, we have a reference to that function constructor function. As weird as this seems, we can actually use this to create new valued functions. So I could do something like let my second function equals test.constructor. Then we pass, let's create something arbitrary, console.log. Let's call it hello second world, whatever that means. And now we're simply going to call that second function. So let's head to Firefox. Let's refresh the page. So notice we get hello second world echoed to the console. In other words, this is syntactically equivalent to writing let my second function equals function and then the function in the string there. That's because test.constructor returns a reference to the function that created this particular object, which is the reference to the function constructor itself. So then we can pass whichever value we want as a string to create a new function. So the question is, how does everything tie together? Well, let's play around with our Angular app. Instead of calling 1 plus 1, let's call on, or you can use eval, but the lab uses on.constructor. Let's just check out on.constructor. Now, if you remember, when we were looking at the scope of this object and the inherited properties, we saw that on is a function. Well, how are functions created under the hood? By using that JavaScript constructor function. In other words, $on.constructor simply returns that JavaScript constructor function. Okay, let's just refresh the page. Notice we get function. Look familiar? That is the JavaScript constructor function. So since that constructor property on our test function returns the JavaScript constructor function, and so does on.constructor, it returns the JavaScript constructor function. That's why we can immediately provide function scopes after constructor. So it's a property that returns a function, which allows us to make use of these scope brackets. We can then pass in the function that we want to create, which is alert in this case. And now hopefully we also understand why we need those additional function scopes. Currently, this is just creating a function using the JavaScript function constructor. But remember, we said that we can dynamically create functions. We can execute them immediately just by providing the additional function scopes. Now, the final question we might have is, why is this specifically a vulnerability with Angular? Why is this just not a vulnerability in terms of being able to inject JavaScript? For example, really logical question here is, well, let's just make use of function directly, right? Let's just make use of function, let's make use of alert, and then let's call a function scope so it becomes executed immediately. Let's refresh the page. It doesn't work. Why doesn't it work? Presumably a security feature of AngularJS. He doesn't want malicious actors executing arbitrary JavaScript for obvious reasons. That's the whole point behind cross-site scripting attacks. We shouldn't be able to execute arbitrary JavaScript. So we are bypassing this security by accessing a property within scope, accessing the constructor property, which returns this function constructor. Then we create our function and call it directly. This is bypassing the security in this case. So instead of function, we're just calling an expression which returns that function, which in this case is $.on or $.eval. .constructor, that returns a JavaScript constructor function. Now we refresh the page, we get the alert echoed to the page. So one of the takeaways I really like from this lab, aside from the fact that we get to do a slightly deeper dive on how Angular works and how also some core functions of JavaScript work, the other thing I really like is it just illustrates the importance of being a researcher. Hacking is not just about copying and pasting some kind of exploit into an input field somewhere. It's about understanding what's taking place so that we can manipulate that particular payload and use it in slightly different environments. The other interesting thing here is that this particular exploit appears to require some knowledge of Angular. So this is something that could easily be missed if we're just trying regular cross-site scripting payloads, like just trying to inject an alert function, for example. We might miss the fact that there's a possible cross-site scripting vulnerability on this particular lab. The other thing we might do here is we might be aware of angle brackets and figure that something's not quite right, because when we put 1 plus 1 inside those curly brackets, then that expression is passed and we actually get 2 echoed to the page. So we might sense that something's not right with that, but then struggle to be able to move to the next step where we have a full cross-site scripting attack. So again, we needed to understand a few basic features of how Angular framework works and just JavaScript frameworks in general. So in this case, we needed to understand what is the scope and which particular functions are available inside that scope. Then also we were able to manipulate that because we understood what is a function constructor in JavaScript and how it's different from the regular way that JavaScript developers will create functions. All right, thanks very much for watching. Hopefully you learned something about cross-site scripting, something about Angular, and something about the way that JavaScript works. Thanks for watching, guys.